G'day guys, James from Kellie Industries here, showing off Cormorant, the world's first dedicated stacked sprite game engine. You may think what we're looking at here is a top-down 2D perspective of an otherwise 2D game, but you'd be partially wrong. What you may be thinking now is that this is actually a 3D environment, and you'd also be wrong. This is fully 2D in that there is only an X and Y coordinate being stored for each sprite that you see on screen. However, it uses a rendering technique known as stacked sprites to create this faux 3D effect. As you can see, I can rotate the camera, pitch the camera, zoom the camera, and move the camera. Those of you familiar with stack spriting may question how this is the first game engine when it is a technique that has been used before by other indie developers. And the answer is that this is written completely from scratch in C# using the monogame framework. Comparatively, other people who have utilized these techniques, and certainly other tutorials you may find online, all do so within a pre-existing game engine, such as Godot or GameMaker. The benefits of using your own engine, such as this, instead of an existing one, is that pre-existing level editors, such as Tiled or those inbuilt into Godot and GameMaker, only allow you to view your scene from a top-down, locked, orthogonal perspective. If I open Godot here, you'll see that while I can use a tool script to render the stacked sprites inside of the editor, I can only move the camera along the 4 cardinal directions. I cannot modify the pitch or rotation of the camera, and so it can be hard to view what exactly the scene will look like from the player's perspective as you play the game. And certainly, if I run the scene, this may not at all be what you're expecting to see from the sample image provided in the editor. In fact, you can see even in the side-by-side, it is quite different and not at all a one-to-one representation of what it will look like in the game. Comparatively with Cormorant, what you see is what you get. This is exactly how the camera will be able to be manipulated in the game, and as a result, you will see exactly what the player sees while developing your levels. You'll notice that if I place a table intersecting the bar counter, that the depth sorting handles it perfectly, almost as if they were both 3D objects in a 3D environment. Believe it or not, this solution is not only custom made, but big O of 1 notation. It doesn't use any computation at all to figure this out. And in fact, there is no sprite sorting whatsoever, as the depth is handled by the sprite batch. Let's say I want to put something on top of this table. So let's grab a lamp and let's try placing it. Well, because there's no z-axis, how do I move it up? Well, I've actually implemented an offset that allows you to manipulate the specific placement of each layer to create an effect that looks like there's a z-index when, once again, there isn't. And we can also rotate the objects as well. So I can actually move this around and it stays on that Z level. And we can rotate it and place it nicely in the world. The engine uses JSON parsing for all of the maps and entities. This means that you can make on-the-fly adjustments without recompiling your code. All the objects you're looking at right now do not actually exist within the game's code. There is no table class, there is no tree class or anything like that. I simply create a generic stack sprite entity and pass through in the constructor a JSON file relevant to whatever entity I want to load. And that JSON file contains all the information such as the sprite location, how many layers it has, and its size. The code is perfectly decoupled. You'll see here in the top right that the editor is a separate executable and the engine itself is a dynamically linked library that the editor hooks into. So you can create any amount of games here that you would want, and they are all separate from one another. So the engine itself does not have a content folder. The editor does, which has all the assets that the editor is using. If you've ever tried to use sprite stacking in the past, you may know that it's not exactly performant. In fact, in a comparison between a sprite stacked scene and a one-to-one recreation in a 3D world using voxels, the 3D environment will tend to perform better. That's not necessarily the case with this engine, as Monogame by default uses a sprite batch to reduce the amount of draw calls per frame, and more specifically, the Monogame extended library allows for vertex buffering. You'll see in this test that there are perhaps tens of thousands of sprites being drawn to the screen with no noticeable FPS impact. If you find this engine interesting, be sure to follow Kellie Industries for updates.